Hey, what's good, chat? 6-7 days for real. We're doing Precalc. What? Oh yeah, 2.7 nonlinear inequalities. Um, stay sigma, guys.
Real thanks for real, my guy. Today's lesson, it slaps, no caps, let's roll. 2.7. As quoted by fam over here, we are going to be checking out nonlinear inequalities. Now, it turns out that one, that is my natural vocabulary. I change it to this when I'm teaching for real. Gross. That's not true. Nonlinear inequalities, we've already pretty much done everything. You guys don't like to graph. I get that. We don't have to. And depends on the question, right? Like if I say, hey, let's make sense of what's going on with this, and you want a graph to make sense of it, you would certainly need it. But for nonlinear inequalities, all we're looking for is when a graph is positive or negative. Now, in this area, just talking real quick, I'm just going to check something from Algebra 2. Do you ever remember doing stuff like this? X squared plus 3 is 3x is greater than or equal to 2. Okay, when you solved these, because there's multiple ways you can do this, some teachers will present it like this, and there's not better or worse. Some people will actually graph this, and you'll say, okay, here's my parabola, and I didn't really graph it that carefully, just so you know. It's somewhere over here. And then you would say, oh, it is greater than 2, or would you rearrange it? Like, did you guys, if we're looking back at it, did you do these problems like this? Or did you just graph it and then find the line through 2 and then identify where it's bigger than this? Okay, so inequalities with shading are different. Those are systems of inequalities. Okay, so I know you've seen something like this. I just don't know how hard it got hit last year in algebra. That's okay. It's super easy. You may not believe me, but check this out. Again, in pink, you don't have to draw it. This is just like an intuition builder. Let's say here's the number A and here's the number B. And I said, here's a parabola. Nope, it's not going to be a parabola. It's going to be something crazy. This thing. And this says function f. And I said, for which range of x values, and I would really say which interval, can you guys tell me an interval where my function f is negative? So turn with your neighbors. I'm going to claim there is an interval, a range here, where my function is negative, and there's a separate range where it's positive. 30 seconds, chat with your neighbors, like real talk, use your lungs and words. Where do you think it's negative?
Oh, you're right.
But I like yours.
It's like down there.
Yeah, love it.
It's like A and then this and an X.
All right, so checking this thing out. We'll talk about the interval stuff because I've heard either inequality conversations about the alligator and what it eats, or parentheses, and you wouldn't say alligator, but that's what I think of when I see inequalities. You guys just tell me the value of my function. When I talk about what is the function, am I asking about the y value or the x value? Like right here, if I said, what's the value of my function? And I'll say this happens, let's say that's 5 and here. Are you going to, if I say what's the value of this function, are you going to give me a or are you going to say it's 5? Which is more natural for the value of the function at this point? Okay, so we're going to clean it up. I'm going to make this function up. It's x to the 4th plus ... I don't know what's there. If I say, what is the value of y? Is it now obvious? What's the value of y right here? So it looks like negative, that's just my dash, but it's just a 5. Does everybody agree that if I say, what's the value of y right here, it's 5? And anybody disagree with that, or we're not sure why I decide that? Instead of y, what is it pretty common that we use? Instead of y equals, we say, so let's try this again. What's the value of f of x at that point? 5. And you would never give me the a value. It doesn't make sense. The function is the y values that correspond to some given x. which that makes it sound uglier, but it's just that. I just need the y value. Okay, so right now, if I start working left to right, and I'll do that here, my function does come up here. I just don't see it, right? Okay, tell me, positive or negative? So I'll actually extend it so you can see me touching it. Positive or negative right here? Positive or negative? Now? You holler when it changes. Oh, it's right here because it changes. Okay, so do we all agree that on these, and I associate the color red with positive because it's hot and blue is negative because it's cold. Like in my head, that's how I think about it. We agree it's all positive here. Okay, and then it changes to negative once it crosses over 0 because it has to, and it's chilly negative down here, right? And then it turns to positive again. Okay, if I give you a graph, is it relatively easy to pick out and say, when is it positive or negative? Now, if you are not confident with that answer, it's really the same question as, can you tell me when it's above the y-axis and when it's below? And that's all I'm asking. That's just a rewording. Now, you guys have expressed, I don't think I believe you, that you're not in love with the process of graphing these. So if we don't want to, and I'm open to still doing it, just for the record, if we wanted to answer this question without graphing, could we? And is that something you'd be interested in doing? Would you rather do it with graphing or without?
With.
Interesting. Didn't you all just tell me you didn't like the last section because there was so much graphing?
Yes.
Interesting. Not what I was expecting, so I gotta figure out how I'm gonna pivot so this fits into what you just told me, and I still do the same thing, but I give you the illusion of choice. For real, that's what's gonna happen. Let's just examine this one for a little while, because even if you guys want to graph all of a sudden out of nowhere, I think it's much easier to do it without, and it's much faster, and we can get the exact same information without actually graphing the function. And it's easy once we see what happens. I know it's positive here, and when does it change from positive to negative? Any function ever. The intermediate value theorem, IVT, might also tell us some of this. When it crosses the x-axis. It can only change signs at a 0 in this example. If I could find the zeros and I just check one little thing, could I equally as easily tell you without having the graph if it's positive or negative there? Now, there's two ways that a function can change signs, and I didn't show both of them here. This one, we agree that a function changes signs at its roots, its zeros, its x-intercepts, right? So we're going to start in here with just this first little preface comment, and we'll get one more picture to make sense of this. For nonlinear inequalities, even before we say the first section, we're just going to make two notes. A function, and I'm going to say a polynomial function. A polynomial, and then really it doesn't matter whether it's a polynomial, but that's what we've been focusing on. A polynomial or rational function can change signs, at, and we're going to put a couple things. There's only two places that we're aware of right now where a function, a polynomial function, could change signs. The first of these we've already identified. What was the first little thing that we identified? It could change here or here. And these are the what? The zeros, the x-intercepts, the roots. Now, I'm going to put a little caveat here. Just because I found an x-intercept, does it guarantee it changes signs? It could bounce, right? So we'll just say it changes signs at zeros if an odd multiplicity. But there's another way that a function can change from being positive to negative that doesn't require the use of the zeros. Now, this graph does not have them, but last night's homework, I've already taken it. Last night's homework had some features that this one doesn't. What did you have to put on all the graphs that you did last night? Ooh, say that again? The asymptotes. Now, you don't have to sketch this, but I just want to see if I can convince you. If I have a function, and I'm going to draw something that has an asymptote, and we'll just make one up here. Is it possible, and we'll do here and here, just for fun. Right here, I can draw, let's say it's stuck in here. Does my function change signs and have a 0? Like, it happened there. Now, we've seen graphs that do something like this. On this side, is it positive or negative right here? Did it happen at a 0? It didn't change signs at an x-intercept. It changed signs at a, or an, asymptote. So Addison suggested this right off the bat. I can see that I don't have to have an x-intercept to actually cross, right? If we understand that asymptotes can allow me to jump like that, from positive to negative. Now, that means if we're looking at solving problems like this, really all we need to know is what are the zeros of my function, or and what are the vertical asymptotes. If you can identify these two things, we don't need the graph of the function. Now, in full honesty, if you guys were sincere and you said, I would rather do these problems by actually graphing the functions, more power to you. You can. You can graph every function. You don't have to. And I'm going to show you the way around it. We are really and truly only graphing a little tiny bit of the function, but I don't care about the rest. Okay, we're just going to jump right in. Where are the only two places that functions change signs? Intercepts, zeros, roots, whatever word you want to use, and the vertical asymptotes. So, without anything else, we're just going to go ahead and say our first section here is going to be called test or testing intervals. And we're going to refine this process, and these problems are going to give us all the same answers if we had graphed it. We get most of the same information, but we don't have to draw the whole big graph and go through all that process. So let's check one out first. Okay, we're just going to jump right into examples, and we'll refine this. There's not going to be any additional homework tonight, but we will refine this tomorrow. So example, I want us to solve each, and I didn't specify, I assume you guys, maybe I shouldn't assume. What is this short for? Did everybody know that when I wrote it?
Yes.
Davian, you've never had me in math. Did you know this meant inequality? That's fair. Is it reasonable at this point, once I've said it, that you think it means inequality? Like, I do this fairly often. If there's ever anything that I write that you don't know what it is, and this is everybody, not just Davian, please tell me right then, right there. Okay, solve each inequality, or inequa, if you want the shorthand. I will actually write it out. Okay, so we're going to have time to do one, maybe two together here. We'll see how far we get, but let's try one. I want us to solve, when is it true that x squared minus 5x is less than 6? All right. Now, when I think of properties, I know this is an inequality, but you guys have solved a bunch of quadratics, right? When we solve a quadratic, do we always use the 6 product property? No, that's dumb. That doesn't exist. Nobody's ever said that before. We use the ZPP, which is what?
Zero.
The zero product property. I don't really care when it's 6. That's a hard question to answer. Could I adjust this so that I get a 0 instead?
Yes.
By doing what?
Subtracting 6 and both.
Okay, I'm going to subtract 6 because working with 6 is not convenient, but when we're working with polynomials, 0 is a convenient number that we always use. So first little change, let's just make this a 0. I think I can subtract 6 from each side, and I get this. Everybody on board with that? So check this out. I don't think your book does this. I've never seen a book do this. I assume every math teacher ever does this. I'm going to make a little comment right here, right now. If I say it is less than 0, very specifically, less than 0, and you'll never see me write this part, what does that mean? Less than 0 means negative. Like just by definition, less than 0 is what we call negative. Okay. So now instead of trying to figure out when is it less than 6, which is an ugly question, we're trying to see when is it negative. That's it. Cool. Gosh, my memory is not great. When can a function change signs from positive to negative? At vertical asymptotes or the zeros. Does this function have any vertical asymptotes? So if you say, I'm not sure, let's clean it up. And many of you are probably not sure. That's okay. How did we find vertical asymptotes? It wears something, the zeros of something. If you need to turn back one page in your notes, do so. The zeros of the denominator. If we divide by 0, we see a vertical asymptote. Is there any x's in the denominator? Is there any chance that I pick an x then that makes me divide by 0? It just can't exist. Are there any asymptotes? No, there's no vertical asymptotes. It's not a rational function. This is just a polynomial. So I'm just going to note that no vertical asymptotes. And if you want the explanation, there's not even no chance to divide by 0. We just don't even have the opportunity. Okay, are there zeros of this or x-intercepts? I want you guys to find them by factoring. Find me the zeros of this function. It's a shortcut, which means it should go fairly quick. We are just factoring right now. Ooh, that's not going to work. -6 and 1 will. Okay, quick review. We have 30 seconds. We're not going to quite finish this problem. The second I find my magic numbers, do I have to rewrite this using 4 terms? The leading coefficient of 1 means there's a what? A shortcut. What's the 2 factors? X minus 6 and x plus 1. And this is my factored form. Now, if I set it equal to 0, what am I actually finding? Despite it's an inequality, if I set it equal to 0, I'm finding the zeros, the x-intercepts, the roots. We'll jump in here tomorrow. Do you guys agree my roots, my x-intercepts, my zeros, happen at x equals +6 and -1? Okay, tomorrow we will finish this problem, and I'm hopeful I convince you guys all to do this without actually graphing the function, but it's up to you. You'll do it without it, I guarantee it. But I'll see you cool cats and kittens tonight at 7 o'clock, hopefully. If you guys don't remember and haven't watched it yet, Tiger King is probably still available on Netflix. And if you want to be really uncomfortable about a lot of really trashy people, you should check it out.